All right, so let's talk about Unit 1, Day 3. We're going to be talking about the midpoint and distance formulas along with bisectors. So let's talk about some vocabulary. A midpoint is exactly what it sounds. It's a point that divides, or a fancy word for divides in half is bisects, a segment, into two congruent segments. So essentially, the midpoint is the middle, which makes sense. Okay, so we're going to talk about the midpoint first, but after we talk about that, remember this, we're going to talk about angle bisectors. So that's similar. So it's a ray that divides an angle into two adjacent congruent angles. So essentially, it's an angle that divides another angle in half, or it's a line, a ray, that divides an angle into two equal pieces. So let's first talk about the midpoint formula. So we're trying to find the middle. So if you go over to -2 and up to 3, put a point there. 4, -1 would be down here. All right, so now we don't have, this isn't a straight line, so you can't just see it, what it is. So I'm going to have to say, I know it's somewhere around here, but is there a way to figure out exactly what it is? So think about it. Wouldn't it be for the x value? Let's talk about just the x value. So right now we have an x value at 4 and we have an x value at -2. Wouldn't the x value of this ray be right in between the two? Yeah, it would. It would be right in here, right at 1. Okay, so let's talk about the y coordinates. So let's just draw a line. Let's draw a line right there where at 2. Or at 1, excuse me. So let's talk about the y coordinates. It'll be in between +3 and -1, right? So that would be at, what would that be at? 1. So that's where it would be if I drew a line. I know my line's a little off, but wouldn't it be right about there? It would. So there is a formula. I want to show you what it is. It's a pretty basic formula. If you think about it, what were we doing with our x coordinates? We were adding them together. So let's talk about our x coordinates. We're finding the average or the middle. So if I had my x coordinates, wouldn't it be 4 and -2? How would I find the average of those x coordinates? I would do 4 plus -2, which is 2, and then divide it by however many we added, which is 2. So the x-coordinate middle would be 1. All right, that's what we had right here in the blue. So let's figure out the y-coordinate. Would be the same thing. It would be the middle of your y values. So it would be average 3 plus -1 would give you 2. Divide it by however many you're adding, which is 2. So this would also be 1. So that's right about where our line is. So it would be 1, 1. Okay? So I think hopefully you get the idea. I'm going to do a few more, but I'm going to give you the formula. So we've talked about this a little bit. How do we find the middle of two numbers? We find the average by adding them and dividing them by 2. So essentially, all the midpoint formula is you're averaging your x coordinates and then you're averaging your y coordinates. So you'll see it written like this. There's going to be 2 large parentheses. And then let's talk about our x coordinates would be x1 plus x2 divided by, so if we're taking the average of those 2 coordinates, dividing them by 2. Okay, so if I have the same exact thing for y, it would be y1 plus y2 divided by 2. That's it. All you are doing is averaging your x coordinates and averaging your y coordinates. So let's talk about the bottom. I'm going to see if I have enough space. It's going to be tight. So if I do, let's say -2, 3. So this will be x1, y1, x2, y2. So if I'm adding my x coordinates, and it doesn't matter because you're adding, you could switch the order if you'd like. -2 plus 5 divided by 2. That's for your x coordinate. And then your y coordinate would be at 3 plus -2 divided by 2. And that would equal, so -2 plus 5 would be 3/2. And then 3 plus -2 would be 1/2. So 1/2 would be your y coordinate. So that would be the coordinate of the midpoint. That's it. Next one, let's do the same exact thing. If you want to try it at head, pause the video, go ahead and try it, and then see if you get it right. So it would be, let's do it, label our points. I like this formula because it doesn't matter the order of your x's or your y's, so because you're adding them. So your x's come first because that comes first in your ordered pair. So 1 plus 5 divided by 2, and this one would be -4 plus 3 divided by 2. So I'm going to write it up above because I'm running out of space. So that would be 6 over 2, which is 3. And then this would be -1 over 2, which is just -1/2. So that would be the midpoint of that. That would be your answer right here. Okay, let's talk about finding the length of each segment. So find the value of x. So you're going to have some problems like this. So if we know the whole thing is 23, because it's right here in blue, if we know the whole thing is 23, and shouldn't each of these pieces added together, they equal 23, right? If all of them or the whole thing equals 23 and they're each pieces, or different 3 pieces, then you should be able to add them all together, set it equal to 23, and solve for x. So let's do that. X minus 6 plus 9 plus 2x minus 19 equals 23. I'm going to combine my like terms. So -6 plus 9 would be 3. Minus 19 would be what? -16. Okay, and then we've got our x values. So x plus 2x is 3x. So 3x equals 23. Add 16, add 16. That would be 39 equals 3x. Divide by 3. X equals 11. And that's it. That's all it asks you to do. Find the value of x equals 11. If it wanted you to find the value of n to m, you would plug in 11. Same thing with L to K or LK, you would plug in 11. That's it. Okay, so points A, B, and C are collinear. Point B is the point between A and C. So if all of these, I always try to draw a picture just so you can see it. If they don't have a picture, draw one. Like right here, they're saying from point A to C is 15. And BC is 7.5. Well, right here we can already see that these mean that they're congruent, right? Those lines mean they're congruent. So the length of AB has to be 7.5. Even if they didn't tell us that they're congruent, if you did 15 minus 7.5, you would still get 17 or 7.5. So it would still be the same answer, even if they didn't tell you it's congruent, but I'm just showing you how to do it. So 7.5 is your answer. Okay, so now we have to talk about angle bisectors. Remember, it is a ray that divides the angle in half. Okay, so suppose if angle PQR is 150 degrees. So that's a obtuse angle. I'm going to wing it and say that's 150 degrees, and I'm going to label it PQR. So angle PQR is, this whole thing is 150 degrees. So if QT, so T will be angle bisector, so it's going to divide it in half. So we'll call that T. What would that divide PQR to? What would be the measure of PQT? So PQT would be right here. So what would that be, that measure? Well, it would be half of 150. 150 divided by 2 would give you 75. So that would be 75 degrees. So 75 degrees would be your answer. Okay, now we get to construct an angle. So construct means draw or make. So this is a protractor. If you notice, it's the same on the inside and the outside. They both go to 180. Depends on which side you want to start from. So first it says construct a 125 degree angle. So I'm going to start here. This might be a little bit harder for me. If you'll have one. I'm going to start from, actually I'm going to start from the other side. So start from here at 0. Then I'm going to go all the way around till I get to 25, which is about right there. I'm going to erase that last line. And so then let's see if I can move this. And I'm going to wing it. Yours should be better than mine because you should have a hole right there that you can draw. So let's say, it's not perfect, but let's say this is a 125 degree angle, which it's pretty close. Okay, so I'm going to move that back on top. See how I did? Not great, but we'll make it work. Okay, so if that is a 125 degree angle, what would be its angle bisector? Well, you'd have to do 125 divided by 2, and that would be what? 62.5? So 62.5. Obviously, we're not going to be able to get exact because we are human, and we're not able to do these 62.5, and this, it's pretty small, so you're just going to get as close as you can. So this would be about right there. Maybe a little bit over, but we'll call that good. So that would be its angle bisector. And then I'm going to connect it. And remember, it is a ray, so it looks just like that. And those look pretty equal. And so if you wanted to say and prove if they were congruent, or just say, you would say this and this are the same. All right, so find the value of x. So just like I did on that last one, you can see both of these angles are equal because of these lines here. So all you have to do, since they're equal, is set them equal to each other and solve for x. So x would equal 40. That's it. Okay, finding the distance. So this is going to be a long video because of this right here, but I'm going to try to make it quick. So if you have the distance, first let's talk about 1, 3, 4, 2. So if these were horizontal or vertical lines, we could just simply count, but unfortunately we cannot. So let's go ahead and, any ideas on how to find the distance? The easiest way, if you have a graph to do it, I would say would be to do the Pythagorean Theorem. So from like here to here to here to here, that now makes a right angle or triangle, and we have our C. Let's call this A and this B. And remember the Pythagorean Theorem, it's one of my favorites, is a squared plus b squared equals c squared. So what is our A? That's 1 unit, so 1 squared. What is our B? That's 3 units. And we're trying to figure out our c squared, or our c, so we're just going to leave that c squared. So 1 squared is 1 plus 9 equals c squared. So then you have 10 equals c squared. Take the square root, and you're going to get an irrational number. So you could either leave it as c equals the square root of 10, or if it has you round to a certain amount of decimal places, like I'll do 1 decimal place, it's approximately 3.1 units. All right, so here's another one. Negative 3, 4, 1, negative 2. I'm going to connect them. And then I'm going to make a right triangle. You could go above or below the line. It doesn't matter. You're going to get the same right triangle. And let's call this A. B, and we're always trying to find C on this. So my A would be 1, 2, 3, 4 squared, plus my B is, what is that, 6 squared, equals C squared. We don't know what that is. So 4 squared would be 16 plus 36 equals C squared, and what would that be? 1252. So then you take the square root, and C is either, the exact answer is the square root of 52, or if it tells you to round, that would be what? I think about 7.2-ish. I'm estimating in my head, so that might be a little off in your calculator. Okay, so what happens if they don't give you a graph? There is a formula. So if you think, let's go back to this one. So if we had these points, and I have my A, B, and C, how could I figure this out? So what's happening from our A's? From here to here. Isn't that the change, or how far the x values are from each other? So this is the distance from the x values, because they're moving horizontally. And isn't from here to here, isn't this the change of your y values? Yeah? So I'm going to erase some of this. This is just kind of for fun. I'm kind of helping you develop the formula. So if we said a squared plus b squared equals c squared. And if I did this and I said, okay, so a squared is the change of x. So let's say, so the change in x for this one would be, let's call this point right here, this would be x1, and this one would be x2. I probably shouldn't label, yeah, that's okay, x1, x2, because that's really what it is in our graph. See, x1 was at 1, x2 is at -3, and how do we find the distance between them? You would subtract x1 minus x2, right? Yeah. So then, aren't we squaring that whole thing? So we're squaring those after we subtract them. We squared the 4. Yep. Okay, and then let's talk about the change in y. So if I called this point, let's call this y1, and this bottom one y2, okay? Our y1 would be 4. Our y2 would be -2, y2. So essentially, wouldn't we just be doing, we did y1 minus y2, because that gave us that distance of 6. If you did 4 minus -2, that would give you 6. And we squared that, and then we added them together, right? Because that's what we did right here. Then we have equals c squared. So how do you get rid of, the c isn't by itself, it's not over. So then what do we have to do? We had to take the square root of all of that business, right? Because if you take the square root, that's what we did at the very end. C squared, if you take the square root, you just get c. So the final distance formula is c equals the square root of x1 minus x2, parentheses, oops, I just realized I wrote the x2 up top as a square, right there. Square it, plus y1 minus y2 squared. And if you ever forget this formula, which is not very handy and it's hard to remember, just use the Pythagorean Theorem. If you, when in doubt, if you forget it, if you don't have a cheat sheet with you, you don't know the formula, just use the Pythagorean Theorem. But let's talk about the next slide where we don't have a graph, and I want you to get used to using the distance formula. So we said the distance formula is c, I shouldn't use the words or variable c, but it doesn't matter. So it's the square root of x1 minus x2, parentheses squared, plus y1 minus y2, parentheses squared. Okay, so let's go ahead and we're just going to plug these in. So we have the square root. I'm first going to label them. Let's call this x1, y1, x2, y2. Doesn't matter. It's like when we found the slope in algebra. It doesn't matter as long as you are consistent throughout. So x1 would be 5 minus negative 4 squared plus your y's, negative 1 minus 2 squared. So this would be the square root of chop, that would be 9 squared, plus negative 1 minus 2 would be negative 3 squared. So this would be the square root of 9 squared is 81, plus 9, so the square root of 90. So you could leave it just like that. Remember, that is your exact answer because this is an irrational number. Or it is approximately, what would that be? I'm rounding off the top of my head, so it may be a little bit different. That would be approximately 9.5-ish. We'll say that. Okay, let's do the last thing we're going to do. Sorry this video is so long. Same thing, let's just practice. So you have the square root. First, let's label. I almost forgot. So I've got my x1 is 3 minus 5 squared plus 1 plus 1 squared. So I have the square root of negative 2 squared plus 2 squared. That would be the square root of 4 plus 4, which is the square root of 8. So that would be approximately what? 2.9. So we can leave it as a square root of 8. That's the exact answer. Or you could say approximately 2.9. And again, I'm estimating. It might be a little bit different. And that is all. Thanks for watching. Sorry it was so long.